Hello, this is Avijit Sarker. I'm a graduate student of Department of Construction Management. Today I will talk about my report. It's a review. So the title of my report is A Comprehensive Review of Systematic Integration of Renewable Resources in Energy Infrastructure Across Diverse Operations. So let me talk about the outline of my report. So the report starts with the introduction, where I basically talk about the motivation, the present current trends, and then the reports that the researches that I'm reviewing on. The second option was the overview of the selected literature. That is how and what literature I find, which system I use to find those research, from where I got all those literatures. I discuss about all these things. I also developed one word cloud and do the analysis. I will talk about more in the relevant section. Then I make some detailed analysis of the selected literatures, where I talk about all the things that the researchers do in overall setting of the report. And finally, I come to a conclusion with discussing the major flaws that I found on those literatures that will give the way to have more scope on further research. So let's talk about introduction. If you can see the picture here that I got from Department of Energy, the thing seems very promising. So there are a 10.3% of the wind energy that is being used to generate electricity currently. 6% is hydropower is used to generate electricity, 3.4% solar, 1.2% biomass, and 0.4% geothermal. So the renewable resources are the one who is getting traction day by day. The next information will be another one, and that is more promising than this. By 2025, it's estimated that the domestic electricity generation by solar energy will be increased by 75%. And the domestic electricity generation by wind energy will be increased by 11%. So you can see that there is a lot of scope in energy realm. So the researchers who are currently working in this region are finding more and more gaps, more and more answers to those gaps, and generating more and more new knowledge in this sector. So I will now talk about a collection of my literatures. So I chose some systematic approach to collect those literature. First of all, I found a pool of literatures from Google Scholars. Then I narrowed down those pools and find 10 based articles that I will use for my report. So of them, most of the papers are from 21 and 22. I also found paper from 2016, 2017, and 2024. So if we look into those literature, they are basically from diverse operations, as mentioned in the title. The one is about the island grid that was dealing about an island in the Thailand. The name of that island is Sumatra. The researcher was integrating one renewable energy in a hybrid form with solar and wind turbine. The second, another one was discussing about an academic building in an university in India, and they are finding the comparison of how much cost that particular system are saving from the amount of energy they are getting from the grid and the energy of amount of energy the renewable energy sources are generating. Then I find one that was deal with a residential community in Ethiopia. They also make a hybrid system of solar and wind, and find out that the system is quite reliable and can serve that community for the entire year. Another one was deal with dealing with agricultural firm. It was about a dairy farm in Algeria. So they implement only the solar energy system to find out how much energy they can save for a year-long time in their farm. And the one that was actually dealing with combined heat and power system to run the prime mover with the help of renewable energy. So on the next step, I do the word cloud analysis, and if you can see, the most cited words here is energy. So as all of the research that I found, the 10 articles are dealing with energy research. So energy is the mostly cited term. After that, the renewable, which is quite obvious because it was dealing with a renewable energy integration system. Every time they are generating some system. So system is another word that is very common. And if you see that is solar and wind, that's because solar and wind are the most popular sources on those 10 papers to integrate the renewable resources into normal grid. And then is the power, because most of the resources were using to generate power. The let's go about the detailed analysis of the literature review. So the literature, when I am deep down into all the analysis they have, I found out some major KPIs. When I quantify those KPIs, I see that about 67% of the research deal with technical and economical viability of renewable energy integration. 22% deal only technical viability, 11% do the environmental, and the 10% do economical. So if I explain more, what was their KPIs in this particular field, like for technical, they use energy yield, system reliability, and grid integration. For economical, they use the levelized cost of energy, return on investment, payback period, net present value, and total cost of ownership. And for the environmental KPIs, they use a reduction of carbon dioxide gas and life cycle analysis. If you can see, this is the literature analysis where I tabulate all the things those literature contains, like the which technology they employed, mostly is commercial software like Homer Pro, PVCs, PVGs, PV wars. Some do some computational modeling and all. They use renewable resources like solar, wind is the most common, and some make it with diesel generator set. And the KPIs that I discussed already are net present cost, cost of energy, return on investment, efficiency, and net present value. So while analyzing all this research, I found some major gaps that are not discussed during those case studies. One of them is the practical load profile. Most of the commercial software that is generating the simulation are taking the synthetic load data, which is not appropriate in some cases. So practical load profile should be implemented so that the result will be very close to the real life setting. Then I saw that there is no discussion about equipment efficiency, so which is another big part. So because the output is highly dependent on the equipment efficiency. The equipment you are using, if it is not efficient one, it will get very less amount of output, and the system might not be technically or commercially viable. And then the system reliability. And it's also another point that is missing in those papers is how the system maintain its reliability is most discussed in it. So I think these are the points that can be discussed in some new research so that there will be new knowledge to generate in energy real. Thank you so much. If you need to know anything more details about this, you can communicate with me in my email address or my phone number. Thank you so much.